Okay, so we're going to extend our trig section. We're going to call this section 7.5. And now what we're going to do is if I give you two sides, we're going to be able to find a missing angle, which again is something that we would not be able to do previously, but we're going to use our trig functions of sine, cosine, tangent. So we're going to use the relationship of SOHCAHTOA. It's just this time on your calculator, we're going to use something called the inverse function, okay? And that function is on your calculator. It is usually the second or the shift, and it's above sine and cosine and tangent. So if you look for those buttons on your calculator, we'll show those to you again, but you're looking for that, that, and that. And again, it's in the associated button. Now, what this does for you is takes the ratio and finds the inverse of it, okay? So when you're dealing with a trig function, to get rid of sine of x or cosine of x to solve for x, you can't divide by it or you can't subtract it. You have to take the inverse. So I think you'll find that the pattern's the same. It's just we're going to use a different function to do it. It still does require us to analyze it. So let's get on with some problems here. So let's look at number 1. So I'm trying to find this angle right here given those two sides. So the first thing I do is I look at these three things. The first identification is which trig function is being shown there. So again, you always look first. I think I look at the 24 and I say, ooh, that's a hypotenuse. Okay, then I look at the other leg, and remember the legs are the ones that can flip-flop. So I got to determine whether that's the adjacent leg or the opposite leg. In this case, that's the opposite leg. So hopefully we're getting a little better at this. So if I have opposite and hypotenuse, right, and that recognizes that it's from it's a sine function. Now, when I want to find an angle, I kind of write it different. Instead of writing sine, I'm going to write sine inverse, and then the ratio goes in here. So it's not going to be a proportion. It's going to be a single calculation on your calculator. So what is that again? Remember that ratio, the order matters. So it's opposite over hypotenuse. Now, again, hopefully your calculator's in degrees. We already hopefully modeled that for you. All right, if you put this in your calculator, sine inverse of 15 or 25, I'd like 15 or 24. Hold on right here, 15 or 24. Right, what you will get then is you will get an x, if you want, of 38.7 degrees. So if you think about that for a second, that's pretty cool, because that's something we could not do before, is given two sides, find a missing angle, unless it's a special triangle, which these are not. Let's go to number 2. Number 2, here's my angle of interest. Here are my two sides. Okay, so if we look at that again, I'm trying to identify what I got there. So I do have a hypotenuse. That's the first thing to look for. So 11 is the hypotenuse. So then 8 is a leg. The conversation is, when your head is 8 the adjacent side, adjacent leg, or the opposite leg? In this case, it's the adjacent leg because it touches it, it's along it, however you want to remember it. That means it is a cosine function. So again, when I'm finding an angle, angles use cosine inverse. Okay, so I'm going to use inverse over the ratio. So how does it go? It matters. Adjacent over hypotenuse. And again, if you put that in your calculator, I'd like you to try it. That angle is going to be somewhere around 43.3 degrees. So again, if you're just watching this, can you put one or two of these in the calculator and make sure you got it? Okay, all right, let's go to number 3. Number 3, again, angle of interest. Do I have a hypotenuse? And the answer is no. So if you've been following, that means it is the tangent function, right? Because there's no hypotenuse. So what leg is this? That's the opposite leg. This is the adjacent leg. So again, to find angles, I use inverse trig functions. So it's the tangent inverse of, again, the order matters. TOA means opposite over adjacent. If you put that in your calculator again, you're going to get x equals 28.4 degrees. And again, decimals all over the place. And we have it. So let's keep going here. All right. So for number 4, what do we have here for this one? Here's my angle of interest. Here are these two. All right. So one of these is going to repeat. So let's look at it here. First thing I can check for is, do I have a hypotenuse? I do. Okay, 23 is the hypotenuse. Then I got to look at the 18. What leg is 18? Either adjacent or opposite. In this case, it's along it, making it adjacent. That means I'm using the cosine function. And again, the order matters. Adjacent over hypotenuse. And if you were to put that in your calculator and get it, I would get 38.5 degrees. okay? So that's pretty much the lesson today. All right, so we'll look at 5 and 6 in class. Then we're going to review a mixture of sides and angles here a little bit. Okay, I do want to go down here and do an application or two. All right, so we have it. So for the application, okay, we're going to go back to the sliding, leaning ladder, okay? So a ladder is leaning against a wall. I like ladder problems, right? So the ladder is leaning against the wall and makes a 75-degree angle with the ground. So 75 degrees. The foot of the ladder is 6 feet from the base. So this is 6. Notice the sort of the natural right triangle form there. Remember, all these are right triangles. What is the length of the ladder? Okay, so I have this. All right. Oh, you know what? I'm going to leave that. That's an application review. Okay, we'll come back to that. Let's go to number 18. Number 18, a kite. Here's the one with an angle on it. Flying a kite lets off 275 feet of string. So again, kite problems. Here's my little kite up here in the air. If there's 275 feet of string, that's this. Okay, if the kite is 150 feet off the ground, right there, here we go. So what that's going to do is that's 150 feet off the ground. Let me get that picture better. All right, what angle does it make with the ground? So we have right here. Now one symbol, I think we've been through this before. I'm going to use a little theta there, which is like a little Oreo symbol. A lot of times when you continue in math here, we're not going to use x anymore because it's been used. So theta is a Greek symbol. That's going to be our angle variable, if you want. Okay, so how do we find that? We should be able to find that at this point then. Okay, so when I find angles, I use inverse trig functions. So which one is this? Here's the angle of interest. Okay, do I have a hypotenuse? I do. All right, so then I have a hypotenuse and one other leg. I gotta look at this leg and say, is that leg the adjacent leg or the opposite leg? In this case, it's the opposite leg. Opposite hypotenuse. Are you following me? I need to do a sine inverse of that. Okay, so for the sine inverse of that, what's it going to be here? It's going to be 150, because the order matters, over the hypotenuse, 275. If you put that in your calculator, pretty cool if you wanted to know it. Okay, theta is going to equal 33.1 degrees. Okay, as far as that goes. All right. Now again, the lesson today is 18, the review is 17. So what we're going to do here then when we go through is we're going to give you a chance, the next challenge after this lesson is to see if you can flip-flop back between the two. I don't think it's too hard that when you want a side, you use the regular trig function, right, of the angle equals a ratio, and you do the proportion. When you want an angle, you take the inverse trig function of the ratio and it gives you the angle. Okay? So that'll be the prep for the lesson, and we'll do some review next time.